Don't say it, Tech. No funny remarks.
Okay, Toby. But it sure looks like you're planning to crawl through that hole. What are you so curious about?
The control cable set up on this new Torqueflite 6 3-speed automatic transmission, Tech. Rod's told me that it was one thing that wasn't changed.
Yep, that's no idle rumor. And for your own information, you'll get the straight dope every time from Raj. He was a shining light in the transmission school of the training center.
Hey, take it easy, Tech. You're putting me on the spot. I don't want Toby to expect any miracles. I was just going to tell him what I learned about the new Torqueflite 6 transmission.
You'd better start then, Raj. Toby's mighty anxious to hear the story.
Well, I've already explained that the Torqueflite 6 is a 3-speed automatic transmission. And Toby knows it's available as an option on Plymouth and Dodge Dart models that have the new 6-cylinder overhead valve engine. Right off, you'll notice that the new unit is a more compact setup than the successful time-tested Torqueflite unit used with V8 engines.
Does that mean it has fewer parts?
Yes, Toby, there are slightly fewer parts. But the outstanding feature of the new design is in the way the parts have been arranged. Because of the new arrangement, it was possible to eliminate the intermediate shaft and reduce the length of the unit.
Oh, then the Torqueflite 6 doesn't work like the Torqueflite 8, right?
Well, both units operate very much alike with these differences. When the number 1 button on the Torqueflite 6 is pushed in, the transmission will not upshift to second. And when the number 2 button is pushed in, the Torqueflite 6 transmission will not upshift to direct, even at high speed. An owner will have to be told not to exceed 60 miles an hour with the number 2 button in because the engine might be damaged. Now, here's something else. Don't push in the number 2 or the number 1 buttons for engine braking above 60 miles per hour. If you do, the transmission will downshift immediately. And throwing that sudden load on the engine might cause some damage.
Attaboy. Now tell Toby about the new throttle linkage.
Right, Tech. This one-piece carburetor throttle rod rotates, which differs from the former type with its fore and aft movement. A small throttle rod bell crank does the turning. The small bell crank is connected to the larger accelerator shaft bell crank mounted in the bracket on the dash panel. An adjustable 2-piece transmission throttle rod connects the larger bell crank with the transmission throttle lever. An accelerator rod with a lower adjustable ball joint connects the pedal with the accelerator shaft. Now, you can shorten or lengthen the rod to obtain the proper pedal angle. The right angle provides a kick down before the pedal touches the floor mat.
So pedal angle is still important.
Oh, that's right, Toby. Now, another external feature that is different is the new one-piece die-cast aluminum torque converter housing and transmission case. It's lighter yet stronger and provides greater rigidity. The new extension housing is also aluminum.
Takeoff taps for installing pressure gauges are in a new location, too. Want to show where they are, Raj?
Yeah, good point, Tech. The front servo release and front clutch apply tap is at the lower part of the front servo cylinder on the right side.
I see it, Raj. How about the line pressure tap?
Well, the line pressure tap is in the accumulator cylinder, also on the right side. And just to the rear of the accumulator is the rear servo apply pressure tap. It's on the rear face of the rear servo cylinder. The governor pressure tap on some models is in the left side of the extension housing mounting flange. On others, it's in the rear face of the case on the left.
Some early units don't have a governor tap.
That's right, Tech. Now, notice the filler tube improvement. The tube with its dipstick fits in a vertically drilled hole in the lower right front corner of the transmission case. It has an O-ring seal and is attached with a clip and screw. The same type of clip and screw attachment secures the speedometer drive pinion and sleeve on the left side of the extension housing. An O-ring in the pinion sleeve groove protects against fluid loss at this point. And when you drain the transmission fluid, you'll find it easier to do a complete job. One plug is in the front edge of the oil pan. The other plug is in the front face of the torque converter.
Okay, Raj. How about the internal differences now? What are they like?
Well, the internal arrangement is different, as I told you. The front clutch has 4 discs. The kick-down band encircles the front clutch retainer. And remember this, the clutch piston applies pressure on the discs from the front. That's directly opposite to the action in the V8 Torqueflite transmission. Now, the rear clutch has 3 discs. Its piston also applies pressure from the front, and the rear clutch uses a Belleville washer instead of a return spring and levers system. Now, located to the rear of the clutches are the front and rear planetary gear sets. Planet pinions of these gear sets mesh with a common sun gear. Around the rear planetary drum, you'll find the low and reverse band. An overrunning clutch is located to the rear of the rear planetary gear set. And that's how the main parts stand in the new arrangement.
Here's something else that's new, Toby. The reverse band adjusting screw is inside the unit. That means you have to remove the oil pan to adjust the reverse band.
I see. An inside job, okay. Kick-down band the same as before?
Yep. But now let's get back to the general arrangement of parts. The front clutch retainer is attached to the driving shell. The driving shell transmits the drive from the front clutch retainer to the sun gear. That's why the intermediate shaft and its support bulkhead became unnecessary, resulting in a shorter unit.
I understand the parts arrangement now, Raj. But I suppose some valving changes had to be made, too.
Oh, sure. One big feature is the redesigned one-piece valve body. In addition to the other valves, it contains the torque converter valve and the regulator valve. These valves were formerly in a separate body. The conventional flat oil screen is underneath the valve body. And in addition, there's a bubble-type oil screen on top. It reduces foaming and keeps air bubbles out of the valves.
Nice going, Raj. You're really giving Toby a good picture of the external and internal features. Suppose we talk about operation.
Okay, Tech, there are some important differences. Hydraulic action is different because variable line pressure is used instead of compensated throttle pressure. But the shift patterns wind up just about the same as they do on the Torqueflite 8 unit. There's a shift pattern chart in the reference book.
Good news, Raj. Now, how about the flow of power through the unit?
Well, that's different, of course. Let's consider breakaway, for instance. In breakaway, the rear clutch is engaged and the overrunning clutch is holding. The flow of power, therefore, is from the torque converter through the input shaft to the rear clutch retainer splined to the shaft. And since the rear clutch is engaged, power flow continues through the rear clutch to the front planetary annulus gear. This gear, in mesh with front planet pinions, drives them in the same direction. The planet pinions, in mesh with the sun gear, turn it in the opposite direction. Rotation of the sun gear, also in mesh with the rear planet pinions, turns these pinions in the same direction as the front planet pinions. The rear planet pinions are in mesh with the rear annulus gear, which is splined to the output shaft. The pinions drive the annulus gear, which in turn drives the output shaft. The rear planetary pinion carrier is held stationary by the overrunning clutch mounted on its hub. So, gear ratio in breakaway is 2.45 to 1, due to the combined reduction of both planetary gear sets.
Let's take a break from breakaway and ask somebody to please turn this record. Raj did such a good job explaining power flow through this new unit in breakaway. How about asking him to cover flow in second or kickdown?
Yeah, Raj. How about that?
Well, I was going to do that anyway. During second, the kick-down band is applied and the rear clutch is engaged. As a result, power flows from the input shaft to the rear clutch retainer. And since the rear clutch is engaged, power continues to flow through the clutch to the front annulus gear. Now, because the kick-down band is applied, the sun gear, driving shell, and sun gear can't turn. Because of this, the front annulus gear will walk the planet pinions around the sun gear and force the pinion carrier in the same direction. Now, since the front planetary pinion carrier is splined to the output shaft, it turns the shaft in the same direction. the carrier moves slower than the annulus gear, which results in a gear ratio of 1.45 to 1. Follow all that, Toby?
Yeah, Raj. No trouble at all. You took me through in easy stages. Now, how about the flow of power when the unit is in direct drive?
Well, in direct, both clutches are engaged and locked together since the front clutch hub and rear clutch retainer are integral. The rear clutch and front planetary annulus gear are connected through the clutch hub. The front clutch and sun gear are connected through the driving shell. So, the front planetary gear set, in effect, is locked up and turns as a unit with the two clutches. Power flow, then, is from the input shaft to the front clutch hub and rear clutch retainer. Now, from there, power goes through the front clutch hub and to the front clutch retainer engaged to the sun gear driving shell and to the sun gear. From there, it goes through the planet pinions to the carrier, which is splined to the output shaft. Now, there's an additional power flow from the rear clutch retainer through the rear clutch and hub to the front planetary annulus gear. Since the front planetary pinions are locked between the annulus gear and the sun gear, the planet carrier is turned with the complete unit. The planet carrier is splined to the output shaft, so it turns the shaft in the same direction. Gear ratio, naturally, is 1 to 1, because all driving units are locked up and there's no gear reduction.
Nice job, Raj. What do you say, Toby?
Still with you, all the way. What's next? Power flow in reverse?
No, Toby. Let's take power flow in manual low, which means when the number 1 button is pushed in. It's a gear used for pulling or slowing down the car. Power flow in low is the same as in breakaway, through the rear clutch and both planetary gear sets, with one difference. The low and reverse band is applied when you push the number 1 button in. That's because manual low is often used as a retarding gear when descending steep grades. The output shaft then drives the engine through the gear reduction provided by the transmission. This, plus engine resistance at closed throttle, provides an effective braking force.
I get it, Raj. Now, how about power flow in reverse?
Well, in reverse, the front clutch is engaged and the low and reverse band is applied. Power flows from the converter through the input shaft and the front clutch hub. Because the front clutch is engaged, power continues to flow through the clutch to the front clutch retainer and the sun gear driving shell that's splined to the sun gear. Now, since the low and reverse band is applied, the rear planet carrier is held stationary. So, when the sun gear rotates the planet pinions, they drive the annulus gear and output shaft in the reverse direction. Gear ratio in reverse is 2.20 to 1. That differs from breakaway's 2.45 to 1, because only one planetary gear set is used for gear reduction in reverse.
Okay, Raj. Power flow is no mystery. Where do we go from here?
How about service tips, Raj? Things that differ from the usual Torqueflite service, I mean.
Yeah, Tech, it's a good suggestion. Let's take harsh shifting or clutch slippage during acceleration. This condition can usually be traced to incorrect throttle linkage adjustment. Now, in a case of this kind, warm the engine up until the choke's wide open and the throttle lever is in idle position. Adjust engine idle to the speed that is specified. Next, loosen the lock nut on the 2-piece transmission throttle rod. Finally, move the transmission throttle lever forward against the stop and tighten the lock nut.
If the accelerator pedal angle needs to be changed, lengthen or shorten the accelerator pedal rod at the lower ball joint.
I can handle that adjustment all right. What's new on lubrication?
Use only automatic transmission fluid type A, suffix A, of course, Toby. But the capacity is different. The Torqueflite 6 takes only 7 quarts U.S. measure, 5.6 quarts imperial measure. You measure oil level the same way you always have.
Drain, clean screens, and refill at 10,000-mile intervals.
That's the ticket, Toby. The refilling procedure, however, is different.
Oh, yeah, Toby. When you refill, pour 5 quarts in first. That's 4 quarts imperial measure, then start the engine. Accelerate several times to fill the torque converter and let the engine run a few minutes more. Add 1 more quart, plus as much as necessary to bring the level up to the add 1 pint mark on the dipstick. That's the cold check.
Yeah, and don't overfill the unit, or the fluid will foam up when it gets hot.
Okay, Tech, I'll watch that. Anything new on the pressure tests?
Well, besides new takeoff locations, pressure specifications are different, of course. But before you test pressure, always measure fluid level. Then you won't get into any unnecessary disassembly. Now, if the fluid level is all right, you would road test the car to see if shift patterns were correct. If shifting were okay, you drive the car about 10 miles so the transmission fluid would reach normal operating temperature. Then you'd measure fluid level again. It should be between the add 1 pint and full marks when the fluid is hot. If fluid level is okay, but the shift patterns are not right, you'd check hydraulic pressures just like you've been doing. Remember, specifications are new. For example, line pressure at closed throttle ranges from 51 to 59 pounds. At near full throttle, it ranges from 88 to 96 pounds. Front servo pressure at closed throttle must be more than 45 pounds. At near full throttle, it goes to more than 80 pounds. Lubrication pressure is 5 to 25 pounds.
You'll find testing and adjusting procedures spelled out in the reference book, Toby.
That's good to know, Tech. I'll certainly look it over.
Attaboy. And that book also has the story on service differences as they apply to the brand new Valiant model.
Okay, Tech. I get the message. I'll make the book my service guide.
In that case, my boy, I'm not going to worry about the new Torqueflite 6 transmission. I can tell it's going to get top service from you and all of our master technicians.